Chapter 9, we deal with circles. The entire chapter is about circles. All kinds of different things about circles. Area of circles, circumference of circles. In fact, I got a whole list of terminology to talk about today. And then we're going to do some weird things like we're going to intersect some circles. We're going to draw some lines through circles. We're going to draw some lines on some circles. Circles, circles, and then when we're done with that, more circles.
Okay.
Points associated with circles. Married?
No.
You're not married? Have you changed your name in the last 30 seconds?
Sokotoa.
Did you just have a stroke? How did you just yell that out? Do you have Tourette's or something?
Oh, no.
Oh, I got it. Sorry. Oh, Sokotoa. What's a center?
You know?
I do, but I'm asking you.
The point in the middle?
Could you be more specific? Hopefully everybody is appreciating the difficulty that Sokotoa is going through right now. And that we all know, if I put a circle up on the board, you could all tell me where the center of that circle is. You know what it is. But again, the difficulty we've had all season, all year, is writing the definition. So, back to you, Mary. What's the center of a circle?
Well.
Good start.
I don't know what to
You want to take a different approach, Mary?
Meaning?
Meaning, what's a circle?
Oh. I forget.
Emmett?
Is the center the point in the middle of the circle that's like equal from all the sides?
There are no sides.
Oh.
There are no sides on a circle.
So if you drew like a point on the circle, it would be equidistant from any point that you drew.
Done. Beautiful. It's the point equidistant from all the points on the circle. Well done. Which is actually how we defined a circle a long time ago. It's the set of points equidistant from a given point called the center. So we're just going full circle here. Full circle, get it, full circle. You didn't have to try. Paul?
Yeah.
What's a radius?
A radius is the distance of the point from the center to any other point on a circle.
So it's a distance? It's a number. Just because I'm asking a question doesn't mean you're wrong. You could just say, yeah.
It's a number.
It's a number. Okay. Michael, what do you got?
Is it a line segment between the center and any other point?
So which one's right? Is it a segment connecting the center and any point on the circle, or is it the distance from the center and any point on the circle?
It's a line segment.
You're going with line segment.
Yeah.
That's one vote.
Line segment.
Line segment, that's two. How many people think it's the line segment? Raise your hand.
Wait, what was the other one?
How many think it's the distance from the center to any point on the circle?
It could be both.
Oh, way to step out. Yeah, it's both. What's a chord? No idea? How if I draw you a picture of a chord? Where's my pen? Saki.
Yeah.
I am a trained professional. Radius. Okay. A number and an object. Center. Let's call that X. The center X. By the way, notation, new symbol, circle, X. I don't know if we've had that before. Have we had that before?
No.
Well, now you do. That's how you do that. Okay, a chord would be something like this. Going from A to B. How do you define that? Rebecca.
A line segment connecting two points in a circle.
Perfect. Well done. Did you all get that? You want to say it again just for the kids at home?
Yeah, a line segment connecting 2 points in a circle.
Any 2 points?
Yeah.
Good. One point of clarification, the center is not part of the circle. Okay? Think of the circle like a hula hoop. Do you all know what a hula hoop is? You don't know? I mean, you guys don't know what a 45 is, do you? What's a diameter? Whoa, screen just went dark. I think I'm blind. There we go. What's a diameter? Subash.
Line segment that goes through the center to the poles and or touches what do you call it, points of the circle.
Say that again. It's a line segment that does what now?
It goes through the center and connects to the end point of the circle. Not end points, the points in the circle.
Any points,
Yeah. Or no.
as long as it passes through the center.
Yeah.
Like that.
Yep.
Good. Is a diameter a chord?
Yeah.
Is a chord a diameter?
No.
No. Good. Okay. Circumference. What is circumference? Shell.
Before I answer, can you repeat the definition for diameter?
Sure. It's a segment that connects any 2 points on the circle passing through the center of the circle. So it's a chord that passes through the center of the circle. Okay. Now what's a circumference?
Circumference is the distance around the circle.
Perfect. Distance around the circle. Since circles are not polygons, circles don't have perimeters. Perimeters are for polygons. Circles are circles. They don't have a perimeter. Their perimeter is what's called the circumference. Well done. That went a lot smoother than I thought it would. Oh yeah, and this new Greek letter here, pi, you've all seen pi before, right? We've used it already. What's special about pi? Where's it come from, other than the button on your calculator? Anybody know?
Pi.
What do you got?
Isn't it if you multiply pi by the diameter, it's the circumference, always?
But that doesn't tell me where pi comes from. That tells me how I can use pi. In fact, we use it not only for the circumference formula, but we also use it for the area formula, which we'll get to yet later. But where'd that magic number come from? What's special about it? Anybody know? What is it? 3.141. Do they still make you memorize as many digits of pi? No, okay. That used to be a big thing, like in elementary school.
Yeah, we had a contest in
In
8th
eighth
grade.
You did in 8th grade. Okay, how many did you do?
I got second.
You only remember 2 numbers?
No, I had like
3.14.
I had like 15.
Oh, what, second place. How many did first place get?
Like 25.
No.
Who was that?
There was someone,
Do you remember?
someone who could do like 100.
What?
Yeah.
Why?
Yeah.
She went to Lincoln, I don't remember who she is.
Does she not have any hobbies? She memorizes 100 places of pi. Wow, that's crazy.
It was, yeah.
Go ahead. Are you gonna tell a story?
No. I
Okay.
was gonna say where pi comes from.
Please tell
Did
me.
you look it up?
Yeah, of course he did. He's got an iPad sitting in front of him.
Yeah, it's the ratio from the ratio.
And he's got a sexy voice on too.
You know I do.
Yeah, oh yeah.
It's the ratio between the circumference of a circle and its diameter.
Yeah. So way back when, like when Euclid and the boys were doing their thing, they didn't have paper, they did all their drawing in sand, so they would draw circles in the sand and then they would measure the distance around and measure the distance across, and then they started realizing that no matter how big of a circle you drew, this number kept coming up, which was 3.141, blah, 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 blah. It's non-repeating, and as far as we know, never ending. So it's an infinite number that never repeats, so there's no patterns in it, unlike like, 0.3333, that would be pattern, this one doesn't have a pattern, and we're gonna use it a lot. Get out your calculators, by the way, just to make sure you
Oh,
can
Madeline.
deal with that.
Okay. Madeline, you know the mode?
Still in degrees,
So like if someone messes
Preferably in
with the
English.
calculator, they can't.
it doesn't have to be. Find the pi button on your calculator. When we do calculations in class, you're going to be giving exact answers and approximate answers. The approximate answers you can multiply out. So if I got an answer like 7 pi, that would be the exact answer, 7 pi. But if we wanted the approximate answer, you would multiply 7 times pi. Don't use 3.14. Use the pi button on your calculator. So tell me what 7 pi is approximately, Rebecca.
21.99.
Beautiful. 21.99. Are we all good with the pi button? Excellent. Even if the directions tell you use 3.14, ignore it and use the pi button. Okay, so circumference of a circle is found doing one of two things. You can do 2 pi times the radius, or you can do d pi. They're the same thing because the relationship between the radius and the diameter is a 2-to-1 relationship. I talked already about exact answers versus approximate answers. Don't screw that up. And again, exact answers should have a pi in the answer. Approximate answers, you'll use your calculator and multiply that bad boy. Which form that you need to answer in will be dictated by the problem. It'll say, give the exact answer, give the approximate answer, give both, or the problem itself will dictate that. Like, for instance, if I'm asking you to find the circumference of a garden because you want to put something around the garden, I don't know, whatever. You're not going to go to the hardware store and ask for 13 pi feet of fencing, because you'll get laughed out of Home Depot. You're going to multiply that out, so that'll become clear in the problem itself. How are we doing so far? This is all review, right? Maybe chord is the only new word? You've heard that one before too. Okay, good. Example. As we start working with circles, and as we continue working with circles into area, you need to get in the habit of starting with a blank formula. So our blank formula in this case would be C is equal to 2 pi times R. Then plug in what you know, then solve for what you don't know. What do we know in this problem?
Circumference.
Circumference, which is 27. Plug it in. You're looking for an exact answer there, so your answer should contain pi. How do I solve for R, Michael?
Divided by 2 pi.
Beautiful. Done. Oh, I forgot something. What are my units? Centimeters. Leave it in that form. You could write it as 13.5 over pi, but it's kind of good math etiquette to not combine fractions with decimals. So leave it like that. What's the approximate value?
4.13.
Wait, hold on, I'm getting two different answers. I got 42 and I got 4.
4.2.
4.3.
42 point.
How is
Yeah,
42?
Whoa,
Yeah,
whoa,
that's right, guy.
41.41.
Yeah.
Can't be 42.
Why can't it be 42?
The circumference is lower than the radius.
Always?
Wait. It should be
What?
higher.
Should be. I mean, I should weigh 200 pounds. I don't.
Not at all in these.
Is the radius always smaller than the circumference?
Yeah.
Yes.
Can you prove that?
Yeah.
How?
I don't know.
That's real simple. You're taking the number and multiplying it by a positive number. It's got to be bigger. Okay, so 42 doesn't work. For those of you that didn't get 42, how are those other people getting 42?
Multiply by like.
Nicole?
I put parentheses around.
Bingo. Woo! If you don't put those parentheses in, what does the calculator do? It takes 27, divides it by 2 and get 13.5, and then takes 13.5 and multiplies it by pi. You gotta put that bad boy in parentheses. Then you get the 4 point something another where the radius is less than the circumference, and so we're happy. Okay, we good?
Yeah.
Beautiful. Rid of that, come back over here, whoopsh. Yeah. We did that, what did you say, 4 point? Oh wait, I probably got it here, 4.3. Okay, 2 nines. Like it, okay.
7, 8, 9.
Okay, good, yeah, just start, continue shouting on numbers, go ahead. Okay, find the circumference of that circle. Oh, smack. Oh, notice it says exact circumference. Got an answer or a question? Yeah. Doesn't matter in that case.
44 pi.
What piece of information are you missing, Ashley?
All the diameter,
Good. What is the diameter?
34.
Beautiful. Which tells us the radius is, do you care? You're just working with diameter, right?
Yeah.
Awesome. So what general equation did you start with, Ashley?
D times pi.
Say again.
Diameter times pi
Good. Equals.
equals circumference.
Good. Assuming that you did that calculation already, did you do Pythagorean theorem or did you realize that that was a triple?
I did Pythagorean.
Okay. Anybody realize that is a triple? It's an 8, 15, 17 triple. Okay, no big deal. She found this to be 34 using Pythagorean theorem. Put that in for D. We get 34 pi for the circumference. Easy. If you worked in radius, then you would just take 34 divided by 2 to get 17, but then you gotta multiply by 2 again to get back to that equation, so you might as well just work with diameter straight up. Okay. Uh-huh. Congruent circles. What makes two circles congruent, Will? Is this circle congruent to that circle? Or back to my original question, what makes two circles congruent? Do you say yes, they are congruent? Yeah. What makes them congruent? Drew? Andrew? No? Is this circle, well, let's pick one. That little guy congruent to that guy? Emmett?
Are they congruent if their ratio of their diameter to circumference are the same?
Can you say that in a more succinct way? You're 100% correct, but
So if the ratio of a circle's diameter to its circumference are congruent, then the circles are congruent.
but ratios can't be congruent unless you have two ratios. You only gave me one ratio.
Okay, if the two circles ratios are congruent.
Wait, why do you keep using ratio?
Oh, okay, so if pi of
Well, now pi comes into it. And I just said pal. You're there, you're just overthinking it. What makes the two circles congruent?
if they have the
You
same
okay?
circumference.
With that? Okay. If they what?
Have the same circumference.
Beautiful. Or,
The same radius,
or,
diameter.
good, done. Okay. Remember, congruent, same Same shape, same size. Well, they're all the same shape. That's easy. A circle's a circle. Same size would be then, how do you determine the size of a circle? The circumference, the radius, or the diameter? Alrighty then. How about concentric circles? What are concentric circles? Have you done prefixes in English yet?
Yeah.
Yeah, what does con mean?
Together.
Together. What does centric mean? Center. So what are concentric circles?
Together centers. Centers that are together.
Centers that are together. Could you draw a picture of that? Of two concentric circles?
I don't know. I can't.
You can?
Try it. I
Good.
don't know. I can't.
What color would you like?
Purple.
I don't have purple.
Blue.
I got blue. I think it's blue. Yeah, there's blue. There's one circle. Oh, did you look at me like I was going to give you a hint? Oh, bed's up. Watch out. Oh, sorry. I thought he was charging.
Concentric. Think of that thing in human geo.
I don't think this is right.
Sit down. Are those circles concentric?
Yes.
Yes, they are. Well done. Sharing the same circle. So suppose you have two concentric congruent circles. What can you tell me about that scenario, Grace?
Can you repeat it?
Two concentric congruent circles. What would that look like?
Just one circle.
Yeah, it's the same circle that you can't. Remember, we're talking two dimensions, so the idea of stacking things on top of each other doesn't make sense. So if they're concentric, they're going to share the same center. If they're congruent, they're going to have the same size, so we'd be talking about only one circle. Yeah, there we go. Like a bullseye. Bullseye is a series of concentric circles. Well, I should say a bullseye, a target in archery, for instance. You know, we used to have an archery team. Yeah. It's our first state championship. When you're in the field house today, look up on the wall, first state championship, archery
They're all
team.
down though. Wait.
Oh,
They are?
Yeah.
They took the states down?
Oh.
Oh, no.
No, in the field house.
Oh, field house.
Yeah, not the gym. Vanessa?
So to be a congruent circles, they have to have either the same circumference, the same radius.
Yeah, because once you have one, you'd have all of them.
Okay.
So once the radiuses are equal, then the diameters are, once the radii are equal, then the diameters would be equal and the circumference would be equal. Ooh, this is fun. Two circles could be the same size. In fact, these are not, they're different size. I would like to figure out how long xy is. I'll give you a second to chew on it before we look at the answer, or to see if anybody can find the answer. We know that this is 5. We also know the diameter of each of the circles. Don't overthink this. Question? Hold on. You have the same answer? Does he have the same answer?
Yeah.
Does she have the same answer?
I don't know.
What do you got? Okay. What do you got? Still working? The counts it, so. Yeah. Too much energy and turn that 90 degrees?
No.
And I'm working on my side.
Do you have any bio homework?
I understand.
Oh, there's green packet over the pink one. Yeah.
There's packed.
Yeah, she gave us a packet when we were looking at
Any answers over here?
the.
I didn't have to touch it all.
No? No?
14.
Grace?
Not yet.
I think I do.
Uh-oh.
Wait.
Is that your final answer?
Are they trading us?
What do you got? So you got 2.
You know the diameter, so just divide.
All right. Let's start with this. How long is that?
8.
11.
Actually,
Oh, sorry,
11,
16.
8, sorry.
Whoa. Time out. Time out. Hold on. Let's start again. Hey kids, how long is that?
8.
How long is this?
11.
11. Okay, so how long is this?
6.
Good. And how? I don't know, hold on. How'd you get 6?
Got it, yeah.
11 minus 5.
Okay, how long is this?
3.
Therefore, how long is that?
14.
I had 20.
6, but yeah, 14. How'd you get 33?
Because
Because the only reason I ask is not to point you out, but you got the same answer. So you guys must have made the same wrong mistake. Did you just add them all up?
yeah, I guess the diameter.
Gotta be no
Yeah, he's not,
Notice, I have 2 overlapping circles. How many points of intersection do those circles have? 2. Good. It is possible to have overlapping circles that touch in only one point, and that's called being tangent. Another use of the word tangent. It looks something like this, and in fact, I have one on the next slide. Okay. Just touch in one point. Touching in 1 point, touching in 2 points. Can they touch in 3 points?
unless they're the same circle.
I'm sorry?
Unless they're the same circle,
But then they would touch in more than
yeah.
3 points. Right. And then you'd only have one circle. Okay. Oh, we're all done.
Squirrel.
Oh yeah, watch this.
You don't have a sound.
He like just flew in the air.
Bites him right in the face. Or her, I'm not sure which one.
That's
It like flew.
All right, we good? Page 1, there is a new assignment